Next is we are going to construct a free body diagram of our structure. So let me just um, write the details here. We have the K1, the mass 1, and then the stiffness at the second floor, and then our mass 2. So if we draw an FBD from our the lamp mass model, magsugod sa second floor no. You're going to start with the second floor. Yan ang itsura. We have an applied dynamic loading, P2. And, sige, if there's an applied dynamic loading, di ba, there is motion. If there is motion, there will be our resisting forces. One of the resisting forces we have that acts on the center of mass or the center of gravity. We call that our inertia force. Let's label our inertia force as Fi2. Fi2 represents the inertia force at the second floor. And then we have also our static force. Let's denote that as Fs2. How about the damping force? Let's not consider on this example the damping. We are just going to consider the inertia and then the static force. So if we are going to sum motion for this one, so to say we have a dynamic equilibrium, and then let's say if the motion or the force is going to the right is positive, then we can write an equation of P2 minus Fi2 minus Fs2 is equal to 0. And then if we just rearrange this just to form an equation similar no sa tuang SDF system, yan yung itsura. Let's say this is our equation 1. Next, you're going to draw the FBD for the first floor. So we have the first floor concentrated or lamp mass, and then we have the columns. So again, we have the applied dynamic force P1, and since there is an applied dynamic load in the first floor, there is an inertia force Fi1, denoting the inertia force at the first floor. And then we have also another resisting force, the elastic restoring force, Fs1. Now, what will happen sa tuang Fs2? If you remember in your mechanics, if there is this transfer, what will happen is the force will be the same in magnitude, but the direction will become opposite. No, mabali siya. So our Fs2 goes to the right in this FBD. And if we sum forces, we'll have P1 plus Fs2 minus the Fi1 minus Fs1. Let me just erase this. Is equal to 0. And again, we just rearrange this. We'll have the inertia force of the first floor plus the static restoring force of the first floor minus the static restoring force in the second floor is equal to 0. Next is let's try to elaborate these equations of motion. By the way, let's call this our equation 2. So sa equation 1, this is our equation of motion on the second floor. This one is for the first floor. Sa to na lang isulat no para dili libog. We have the first floor and then the second floor. Okay. So if we are going to elaborately write down the equation now for the second floor, the inertia force diba is mass times acceleration. So since we have first and the second floor, then we are going to put a subscript to denote second floor and first floor. So the inertia force in the second floor, we are going to write that as the mass of the second floor times the acceleration of the second floor plus the static force we have the stiffness of the second floor times what? Times the deformation of the second floor minus deformation of the first floor is equal to P2. And why is this? Ano yung naman? Okay, tanaw na to ang drawing. So let's say no, this is the U1 deformation of the first floor. If we project this sa ibabaw, this is our U2 deformation of the second floor. Again, with the static force, kano sa man nag-react ang static force? So, during deformation, let's say naa na siya diring apart, no? And because of the applied force, ni-move din siya to the right. And since nagtungtong man siya diri no ang column, the column is only resisting this specific deformation. Pila man na siya? Pila ang distance ana? Pila ang deformation ana? That is the total deformation of the second floor minus the deformation of the first floor. That is the length. That's why our Fs2 is just, we have the static force times the difference of the deformation of the second floor and the first floor. So if you're going to write the second equation for the first floor, Fi1 will just be the mass times the acceleration, m1 times u double dot 1 plus Fs1, so we have the k1 times the u1. So u1 na lang ni siya because our static force or the column in the first floor is just resisting this part or this deformation, which is u1. And then minus Fs2, that is minus k2 as u2 minus u1 is equal to p2. So let me just cut this video, and then we're going to continue in the next one for the expansion of these equations.